So let's take a look for the second part. We started by introducing the graphics structure and tell you how to do the data display. But now we need to come back to the main topic, the image display. Okay, not only the data points but the image display. And specifically, I'm going to introduce what is the color map. Okay, what is the color map? So again, you can see right here, not only what we have before. Now we are going to focus on the images, right? For this first part, we are talking about something for the line. But right now, I have to say, you can see under the axis, you can also have a child like the image object right here. So you can see the example. You can have a figure. Under this grandmom figure right here, you can have an axis. You can name it as the mom, and then under this mom, you can have a child you can have a child which is an imaging object right here. Okay, so again, you can see this kind of the hierarchical relations between all these objects right here. So again, I want to emphasize that you need to have an axis, then you can have the imaging. But you may ask me that for the previous weeks, we only learned how to use image show, right? So I have to say, again, image show is pretty like the plot. It is kind of a function that's very convenient, but sometimes you cannot really learn the object or the graphics structure when you are using the image show, because that is too convenient, I have to say. The author package everything within the image show. But actually, when you are creating a new imaging, what you should learn, what you should know is that behind the imaging, there is an axis. And behind the axis, there is a figure. Okay, you need to really understand this. So when we are talking about an image, I think you may have the idea. You can see on the right-hand side, this is an MRI, the magnetic resonance imaging for the foot and the ankle. You can see right there, okay? And we always know that for this kind of the medical imaging, it's actually nothing but just like a matrix, okay? So you can take a look right here. If I try to zoom in or focus on this red box area right here, take a look. This is something that I get from this local area. Take a look right here. If you try to figure out what are these numbers represent, think about this. If you see a very small value, that may represent some intensity or color pretty close to black, okay? If you are looking at some values that is actually pretty huge, it may be the intensity or color pretty close to the white. So think about this. You may find out there is a border. Let me draw it for you. You can see for this part, there are only 2 digits, right? But for this part, you can see there are 3 digits right here. So maybe we can create a border right here. Let me just try to plot it. You may see there is a border right here, right? Let me draw it very carefully. You may see something right here, right? I try to give you the area for 3 digits number right here. Yeah, pretty like this one. So I have to say, you may see actually intensity can be transferred into the grayscale. What is grayscale? This is the grayscale. That means between white and pure black, there are several different levels. We said they are grays, but they may be light gray, they may be dark gray. There are several different levels. So we can say this is so-called gray level, or we can use the plural gray levels. Typically, we may have, for example, 256 different gray levels between pure white and pure black right here, okay? And for different level, it can be assigned into a specific pixel value. For example, 0 is black. 500 is white. So if you have the value between these, for example, 300, then it may be the gray level around here, right? So 0, 500, so here may be the 300, okay? So now think about this. Please link the pixel value with the gray level, okay? So if you do understand this, you may immediately find out that even you only have an image matrix like 250 by 250, you can actually transfer it into an image. And if you do have a good gray level bar right here, you can actually display something like this one. You can see the difference between tissues, right? Here is the bone, here's some fat, here's the muscle, and you can see the tendon or something right here. Because we can see the difference between different gray levels. Okay, that is so-called contrast, right? That means the difference between tissues or difference between gray levels. Okay. So now I'm going to tell you another thing. If I'm trying to replace the gray level by, how about color level? Okay, you can see the previous example right here. This is so-called gray level. That means the lowest value would be black, the highest value would be white, right? If I change this gray level into so-called color level, but I have to say color level is a little bit weird. So normally we say color map, okay? Color map. So now you can see the lowest value, again, it may be, maybe it is not pure black, it's more like the dark blue anyway. But again, you can see the highest value would be white. But in between, they are not simply grays. You can see different color, right? So black, dark blue, blue, purple, red, maybe yellow, green, and then you can see it's gradually changed into white, right? So you may find out important things. I didn't change any value within the image matrix. You can see the value are all the same. The values are all the same, right? The only thing I changed is the color map. If I change the color map to this one, now again, this is for 0. So let me put the number right here. For 0, it is right here. This may be, again, the 500. But now, again, I can put the 300 right here. For the previous example, you may see 300 may be this kind of the gray, right? But if I change the gray level into a color map, you will see now this light gray becomes yellow right here. Okay, so you can see the value of an image matrix itself, it doesn't change. The only change is the gray level or color map. This is the way that you can switch between, black and white or the color image right here. Okay, so the key is this one. The key is this one. Can you provide a proper color map to help you actually observe the medical imaging? So think about this. For this example right here, the ankle MRI, do you like this one, grayscale, or maybe this one? Which one do you think that can really help you to differentiate different tissues? Yeah, I think different students right here, you may have different preference. You may like this one, but some of you may like this one. But I have to say, in the real world, in the real workstation for this kind of a medical imaging, it up to you. You can easily change the color map. Whether you like the grayscale or you like the color map, you can easily change it, okay? This is what we are going to practice today. So think about this. We can just take this very simple example right here. For example, if we only have 1, 2, 3, 4, 5, 6 levels right here. You can see, again, within the imaging, the highest value would be assigned to white. The lowest value in this case may be yellow. Okay, you can think about this. But I have to say, actually, the order would be reverse to 1 because for the array, for example, this is a 6 by 1 array, or you can say 6 by 3 array. This is the first row. So I have to say this is the lowest value. First row, second row, third row, fourth row, fifth row, and the sixth row right here, okay? So you can think about this. In this example, we have 6 different colors for 6 different labels. But right now, I need you to learn a new concept about color. How can we really determine the color? In MATLAB, we commonly use this kind of the idea, RGB factor. R represents red, G represents green, and finally B represents blue, okay? RGB factor. So you can see RGB factor, you can see the sentence right here. Each color is composed of 3 numbers as a 1 by 3 factor. Again, for each element, it would represent red, the component of the red. The second element would represent the color of green. The final one would be the blue, okay? So you can see this matrix right here. So for the first column for red, then second green, the final one blue. So what is the code? What is the code? What is the RGB code for white? The answer is 111 because this is so-called light color. So if you have all the light right here, it will create white. How about black? Black means you don't have anything, right? 0, 0, 0, then it is black. How about red? The pure red would simply be 1, 0, 0 because you only have red component, you don't have the green and the blue, right? So similarly, for the green, you get 0, 1, 0 code right here. So I have to say again, each color can be represented by a 1 by 3 value following the RGB coding, okay? But there's an important thing for some programming language, they may use the value between 0 and 255. But for MATLAB, we always set the value between 0 and 1. So 1 means 100%, 0 means 0%, okay? So for example, yellow. Yellow is the mix for both the red and green components, so you need to put 1, 1, 0, okay? So in order to help you learn the RGB code for a specific color, you can key in UI set color in the command window. Let me do this for you. You can key in UI set color. Okay. MATLAB will create this small figure right here. And now what you can do, you can see different color right here, right? Then you can move your cursor to a specific color and wait. Just wait. You will see there is a small factor right there, 1 by 3. For example, this one is pretty like yellow, right? But not pure yellow. So you may see the number right here is 110.07. The pure yellow should be 110, right? But this one is 110.07. And for, again, this one is pretty similar to the pure blue, right? So you can see the 1 by 3 factor is 001. Of course, if you want to use, if you are seeking for much more complex color right here, you can just switch any place right here, and you can move this right here, okay? So you can see this is the point you select, the color you select, and you can see the RGB code right here. Okay, so you can use this kind of the UI set color to help you understand the RGB code for a specific color right here. So let me give you some time. Try to use the UI set color to learn the RGB for different colors. So doing now, try to create any color and try to observe what is the value of the RGB, okay? So you need to do it now, then you can learn what is the RGB code, okay? So I think it is straightforward, right? And you just pick a color and just learn what is the RGB code for this. Okay, so let us continue. So every single time if you want to create a color and you don't know the RGB code, just use the UI set color. then you can find it out, okay? So now I have to introduce a new concept. What is the color map? Okay, what is the color map? So now think about this. If I really want to assign different color to different matrix value, or sometimes we say intensity. For example, 0 should be black, 500 should be white. This is kind of the assignment or kind of the match, right? So you can take a look right here. You can create a color map using this way. Take a look at what does this mean. Actually, CMap is the variable name of this color map. And you can see I use the equal sign right here. That means assign, right? So now you can see for the right-hand side, it should be a matrix, always with 3 columns, because we are using the RGB code system, right? So always come with 3 columns. But you can have as many rows as you want, okay? For example, if you want to create 200 different color label, you can create 200 rows. So this kind of C map variable should have the size around, should be the size of 200 by 3, right? But if you only want to have 6 different color label, you can just go for 6 by 3, right? So you can see we always put a semicolon right here. That means change the row, right? So 0, 0, 0, you can see change the row. It becomes the 1, 0, 0. So this one is the white. This is red. This is green, right? The final one is, sorry, the first one is black. The final one is the white, yeah. So think about this. The CMap should always be n by 3. N by 3. N is the number of the color label you'd like to have. And you can see the instruction right here. For the very first row, it would be the color for the first intensity, okay? And for the final row, it would be the intensity for the maximum value right here. For example, N label, that means N value right here. Okay, so you can think about this. We have not only the image show. Image show is something we are pretty familiar with, right? But now I'm going to tell you we do have another function for image display, IMAGE. Actually, you can use both of them to display the image. But I have to say again, image show is a packaged function. It is something that designed to help you easily display the image. But the image function right here is actually the graphics object. So once you use the imaging, you can see the axis, you can see the figure actually, okay? So, and for the default value, if you are using the image show, the default color map would be the grayscale. If you are using the image function for image display, it will use this one. This is the, I think the new version for the MATLAB display. It is a kind of the color map. And actually in MATLAB, there are so many different default color map you can use. Okay, you don't really need to always create the color map by yourself. So you can see grayscale. Okay, gray is one of the most common thing that we used for image display. But actually, we have several different color map you can use. Okay, so this is the default one, but you can change the color map to jet. You can change it to the HSV. So if you may recall, for the midterm computer test, I do ask you to create a color map using jet, if you do remember, I hope, okay? But there are so many different things you can change, okay? So no worry about this. So now I'm going to ask you to key in these 4 lines into a new script, okay? So you should be able to see these kind of things. So do it now. And I want you to think about what is the relation between the intensity, that means the values within this X variable, and the color map right here. I want you to find out the relationship, okay? So try to key in these 4 lines into a new script and think about this. What is the relationship between the value of X and the color map? So think about this. I know X this x variable is a 2 by 3 vector, right? But why I can see this kind of color right here? I know this is 2 by 3 matrix. I can understand, right? This is x. But why? The first element for x is 4, right? Why 4 is yellow? Why 5 is pink? Or why 6 is another color? I don't know. So think about this. Why you do have this kind of the color right here? There is a hint for you. Once you do have the figure on hand, you can click this button. Just try to take a look right here. Let me take the control. You can click this button, insert color bar. You can press on it. You will see these kind of things, okay? Try to think about this. It will help you to immediately understand the relationship between the matrix value and the color map, okay? So you can see the first element for x is 4, right? So you can see 4 right here. Okay, this is yellow. So second one is a 5. So you can see, okay, 5, this is color, okay? 6, this color, right? Okay, so I have 6 different color label right here. It will help you to find out the corresponding value and display the corresponding color right here. Okay, so the right-hand side, this is so-called the color bar. Color bar can help you visualize the color map. Okay, so if you really want to know the value right here, you can also click on this data type tool right here. Okay, you can also click on it. You can see the value is 4. You can see the value is 5. You can see the value is 6. You can see the index value is 1. Okay, so it would be the red. Okay, so think about this. Think about this, okay? And now you should be able to understand that this is the matrix that I have. Okay, I use imaging. I didn't use image show, right? I use image. So you may find out something. Image show, normally when you are using the image show, you want to see the axis right here. Okay, so let me do this for you. I can do something pretty similar for you. Let me create a new figure, but now I want to replace the image show by, image by image show, but I'm doing the same thing. Let me see what would happen, okay? So you can compare what is the difference between image show and the imaging. Okay, so the very first thing you can see right here, yes, this one is for imaging, the first figure, right? The second figure is pretty weird. Why it is pretty weird? You see nothing, but actually there is something. Take a look. Take a look, there is something. You can see so small, right? Because image show will use the original size, but the imaging will help you to, enlarge. Even you only have the 2 by 3 matrix, it can help you to enlarge. So I have to say, if you only have a very small matrix, you can go for imaging. And the second thing is that even you click this on, it's just too small to be seen. Sorry. Anyway, it's just too small, so I cannot show you this example. Anyway, just try to do this by yourself. Try to compare what is the difference between image and image show. Okay. So anyway, let's just focus on the image right here. Okay. But right here, you need to remember one thing. For the code line number 3 right here, this is the way that you can create a C-map matrix. You can see this is a matrix with a size 6 by 3. That means I have 6 different color labels, right? But if I really want to apply this C-map into the display, the image right here, I need to use the color map. Color map is the function that to help you apply this kind of the color label into the display, the image. Okay, so without this one, for example, without this one, you cannot see the right color. So let me run it again. Let me do it again. Yeah, you will find out what's happened right now if I just simply, mark the line number 4. You can again click on insert color bar icon right here. You may find out, no, this is not the right one, right? If I create the C-map, the MATLAB using the imaging would come with the default color label. Normally, it would be 256 different color label, but this is not what you want. So if you really want to apply this customized CMap, you need to call the colormap function, okay? And I simply mentioned that actually there are plenty default map you can use, like this one, right? So instead of create the color map by yourself, actually you can switch between different things. For example, let me show you. We did mention that we do have this one, right? Gray. You can see gray right here, right? And you can give gray a number. That means how many labels do you want? So in this case, I didn't use the customized CMap. I use gray. This is some default color map, right? Let me do it again. You will find out, wow, it is actually black and white because it used the gray. And you can change to different color map, for example, HSV. Again, I want it to have 6 different labels right here. Okay, then observe this. Okay, so you can see it's pretty similar to what we did, but a little bit different because, again, the color map is pretty different. So we do have several different default map that you can use. For example, the hot. Look like pretty hot, right? So you can see from dark red to white. Okay, so you can either use the default color map created by MATLAB team, or you can use the customized color map. But do remember, it should always be, the size with 3 columns. Okay, this is very important. Okay. So now I think you can understand what is the difference between these two. Actually, the image matrix itself are identical. The only difference is the color map that we used. Okay, is the color map that we used. So I do prepare this M file, image exercise 11.m file. So you can actually open it. Let me open it for you, this one. Okay. You can simply just run it to check what you can have. So you can have figure 1 and figure 2. Figure 1 is for grayscale. Figure 2 is the color map right here. So you can go through the detail. We see in today's folder, there is a so-called food imaging.mat file. Once you read it, you will get an image right here. The size would be 350 by 350. So you can go through the detail, a lot of the values inside. But you can see they do have some floating points, right? But for image display, I cannot create 3.6 label, right? So basically, we will get the integer value. You can either use the round, floor, or even the ceiling to get the close to the integer right there. Okay. So you can take a look right here for the code number 7. It is actually the rescale. I try to rescale the imaging between 0 and 255. So let me do this for you. And run this part. Yeah. Okay. You can see the maximum value of the imaging. Sorry, I should have with this one. It will be 255. And the minimum value would be 0 because we are doing this one. You can see I subtract the minimum value of the imaging from all the elements and divided it by the range. You can see I use the maxima subtract by the minimum value of the image. So this is the image range. So basically, this is the way that I can make sure all the imaging intensity or image values are between 0 and 1. And for code line number 8 right here, you can see I rescale it to 0 and 255. Okay, so this command line 7 and 8 can help you to make sure you can set all the image values within the specific range that you really want. For example, between 0 and 255. Okay. So if the minimum value is 0, the maximum value is 255. How many color labels that I should have? To be very honest, it should have 256, right? Because 0, you start by 0. 0, 1, 2, 3, until the 255. So basically, you need 256 color level or gray level for the display, okay? So you can see for the first figure, I simply use the image to display this matrix. However, I use the gray with 256 level to display this image. So this is the very first one you can see, right? You can see I do have the 256 level right here. This is for very first image. But you can see for the second image, I use the same image matrix, right? Everything is the same, right? But the only difference is that I use different color map. For this case, I use gray 256, right? But right here, I use a customized color map created by myself. Okay, so I can show you this thing. If you really want to understand this part, think about this. For the very first part, I create the imaging started by black. Then I want it to gradually change from the black to blue, blue to red, red to yellow, yellow to white. You need to think about what is the function of the link space. And you need to think about what I'm doing right here is I try to create the color map following the order. So what you can do right here, I would recommend you to do this. You can simply copy just one part. For example, you can copy this part. Okay, you can simply copy this part. Try to observe what does this mean. So let me do this. Okay, so you can take a look. For the very first part, you can see I simply create something start from 0, 0, 0. That is black, right? Then it will gradually increase the value for the third column until it becomes 1. So that means blue, right? So you can see we will have the gradual change from black to blue. Okay, so this is for very first part. That is the reason why I say this is a start from black, ended by blue, right? So pretty similarly, you can check the second, third, and fourth line right here. It will help you to create the color map, gradually change from the blue to red, and then so forth, so on, okay? So this is something you can check, okay? So please check it by yourself, and I'm going to give you 1 or 2 minutes, then I will explain the homework today. But right now, please just take 1 minute to figure out whether you can understand this part, okay? So again, I just want to emphasize, if you want to create a color image, you don't need to change the image matrix itself. You don't really need to change it. The only thing you need to change is the color bar or color map, okay? I see many of you are eager to get the homework done. Anyway, so I don't want to delay your time, so maybe I can explain the homework. If you do have the problem for the previous part, you can still raise your hand and TA will help you, okay? But right now, you can just listen to me how to finish your homework for this week. So again, we are going to use this foot image. Okay, this foot MR image right here. But I need you to get the final result, exactly like what you can see on the right-hand side. Basically, this is a grayscale image. However, for specific pixels, I'd like you to display it in red. What is the criteria? Take a look. First things I have to say, for the pixels with intensity or value lower than 600, you don't need to do anything. It can simply be displayed in grayscale. But you can see the very first thing, I want you to use find to find out the locations or indices of all the pixels that are higher than 600. Okay, this is the very first things you need to do. You need to use find, like IND equals to something, okay? Just find all the pixels with the intensity larger than 600. And the second thing, you need to rescale all the image intensity to be between 1 and 255. It's a little bit different because for the example that I just showed you, I rescale the range between 0 to 255, right? But right here, I'm asking you to display the range between 1 and 255. I need you to think about this, how to manage it, okay? How to really rescale all the values between 1 to 255, not 0 and 255. Think about this. So overall, you only need to spend 255 grade levels. In the example that I just showed you, we spend 256 grade levels, right? Because we also have the 0. But right here, we don't have the 0. Okay, we start from 1. So basically, you would have the 255 grade levels. But the final thing is that you need to find out the pixels, right? We already find out the indices in the very first step, right? I need you to set the intensity or the value for these indices to be 256. And then you need to think about this. I'm going to telling you the answer, right? The color map should be something like this. You need to set up your color map not only using 255 grayscale, but also you can see I change the row, right? I change the row and I add red in the final row. So you can see this is a semicolon. This is the final row or final label. It should be red, 100. So that means the pixel values with 256 would actually be displayed as red. Okay, so not grayscale because grayscale is only for pixel values between 1 to 255. But the pixels that have been set up to has been set to 256 would be displayed in red. Okay, so I zoom in this part. If you display the color bar right here, you can see for the highest level right here, 256 row right here, it should be red. Okay, it's just too small, so I just zoom in it for you. Okay, so think about this, whether you can do this or not, just think about this. And feel free to discuss with your group member, okay? From now on, you should work together because you are the team, so do it with your friends, okay? If you do have any question about the today's content or even the homework assignment itself, you can just raise your hand.